What you're going to see today, and I do really want to encourage you to watch the videotaped presentation from this morning, because we discussed Dimetrodon. We have, up until recently, only dug in the Cretaceous, which is surmised to be some 70 million years old or a little bit younger. And the amount of soft tissue that we're finding is abundant. I made the prediction in 2012 that this would be the norm rather than the exception, and that's now proven true. And so I would encourage you to see that presentation, because we're not only finding blood clots in Dimetrodon, and I'll explain that, why that's significant, but we're also finding the best nerves we've ever seen, even better than these nerves that we pulled out of Triceratops. We're finding better preservation in the Permian, which is at about 275 to 290 million years old, according to the literature. So I'll tell you a little secret. We're actually also looking in the Devonian, which is 100 million years even earlier than that, and plenty of preservation there. So it's a great presentation. It's brand new. It was just published in a journal this week, and so I'd encourage you to get that video. The Dinosaur Soft Tissue Research Institute is a 501c3 organization. We're a research organization. We go to the digs, we bring the fossils back, we prepare them, we extract the soft tissues from them, and we publish, but we present also at scientific meetings. So we're going to some of these meetings. We're also speaking on college campuses. We're going to speak at University of Texas, El Paso in February. We spoke at Penn State University and State College in November. And that was broadcast online, and the comments coming in from the students who were saying, "I cannot believe I'm hearing what you're saying," was fantastic. So we would appreciate your encouragement and support as we go out and take this to the world, because the world needs to hear this, and they're not. They're not hearing it. So that's why we're going out on the road. But please watch the lecture from this morning. This afternoon, I thought what I would do, I'm going to tag team with our president here, Keith Holcomb, who's going to address you at the end. But I wanted to show you some of the latest, greatest stuff right off the bench. So this is stuff that I photographed last week. So this work is ongoing, and you'll get to see some of this. So in May, no, actually it was October, we went to Montana, 2021. Before that, we went to the Permian in Oklahoma, which was the talk this morning. But we did end up going back to the Hell Creek, and we dug there, mostly for Nanotyrannus. Now, Nanotyrannus is a controversial dinosaur because some people claim it's a T-Rex, a juvenile T-Rex, but it has some very distinguishing features that distinguish it from T-Rex. So we think it's a brand new dinosaur that is controversial, and that's why we're going to collect tissues on it, because it's already controversial. So, you know, you want to tie your kite under one of those strings, right? So we collected mostly Nanotyrannus. I do have a Nanotyrannus rib up here. I mislabeled it. This is Nanotyrannus, and you guys can come up and handle these bones, by the way, after the talk. And we also have some Permian limbs here that you could look at. But we collected Nanotyrannus teeth, claw, vertebrate, rib. We didn't get jaw, but we got quite a bit of material, some long limb bones, which are beautiful. And so we dissolved those. We wrecked the fossils, right? Paleontologists don't like us because we actually destroy them. We turn them into mud, frankly, through our decalcification process. And then we extract the tissues. And this is what we're going to teach the kids to do, the students. My philosophy is, if you want to reach a PhD secular scientist, train a 13-year-old and they'll teach them, because they'll do it. They'll do the job. So that's what we're trying to do. All right, so let me show you some of the results that we got from Nanotyrannus. We found beautiful claws. By the way, I have a very powerful pointer here. It's low tech, but it works really well. So that's a claw, Nanotyrannus. These are fresh out of the ground. Okay, they're almost pristine. These are buried in sand. So there's really hardly any digging. It's mostly just shaving the sand away with a spatula. Teeth, beautiful teeth, and the Nanotyrannus teeth are serrated on both sides. So this was a steak knife coming and going, yeah? He could slice right through you. Plenty of limb bones. I showed you. This is actually part of this rib that is presently in decal in my lab. And we're pulling beautiful nerves and cells out of this, and you'll get to see some of those. This is one of the long limb bones that I was talking about. I mean, this is upwards of 6, 7 inches long, and we found longer ones. Remember, this work started by looking at femurs only. The scientists who first worked with soft tissue were mostly using femurs. Why? It's a big, strong bone, yeah? It's fully encapsulated. It's got a really thick amount of compact bone around the outside, and then all the spongy trabecular bone in the inside, and that's where a lot of soft tissue is. So everybody was going out looking for femurs. Well, we went looking for a femur, we found a horn. It was fractured, broken up, wet, full of plant roots, fungal bodies. We counted the DNA of 60 different individual animals and plants in this very specimen. So how is this soft tissue here after that onslaught? I don't know. I don't know why it's here, but the preservation mechanisms that our colleagues are proposing don't work. And if you watch that presentation this morning and you look at the blood clots, you'll understand that your blood clots when you drown. And we're finding clots in every single one of the bones that we thin section. That means they all drown. So there's hard clinical scientific evidence that it was a drowning event that was the demise of these creatures. Anyway, the preservation is fabulous. Like I say, you just dig them out of sand. This is all just sand. See that? It's all just sand. And there's, you go up against the wall and you just dig into the wall and you find bone after tooth after claw. It's amazing. So if you want to come on a dig with us, let us know. We'll probably put you to work, but you'll have a great time too. We go on 3 or 4 different sites a year.